drawing of the machine elements and simple parts. 2. Learning objectives. At the end of this topic, you will be able to know the overview of production drawing, analyze the need for drawing conventions, describe Indian standard conventions, explain national standards, know the range of engineering drawings. Outcomes. By the end of this topic, you will be able to know the applications of machine parts, effectively utilize the machine elements and parts. Threaded parts. Thread can be formed on a regular cylinder or on a tapered cylinder. The focus here is on the threads formed on cylinders. The thread form of geometries such as conical, square, trapezoidal, half-round, wrapped on the base cylinder in the form of a helix in right-hand or left-hand direction. Right-handed thread is normal. The helix could be with more than one start. When more than one, it is a multi-start screw. For one turn of the screw, the multi-start travels more by the number of times of starts. External threads can be cut on a lathe or formed by rolling between forming rollers. Their widest application is in all types of fasteners, but they have many other uses like in conveyors, screw pumps, lifting devices, etc. Bolts. Some basic forms of bolts. Square-headed bolt with square neck. It is provided with a square neck which fits into the corresponding square hole in the adjacent part, preventing the rotation of the bolt square neck. T-headed bolt with square neck. A square neck provided below the head prevents the rotation of the bolt. This is used for fixing vices, workpieces, etc. to the machine table having T-slots. Hook bolt. This bolt passes through a hole in one part only, while the other part is gripped by the hook-shaped bolt head. Eye bolt. It is used in lifting of heavy machineries like electric generators, motors, turbines, etc. For fitting an eye bolt, a tapped hole is provided above the center of gravity. Stud bolt. It consists of cylindrical shank with threads cut on both the ends. It is used where there is no place for accommodating the bolt head, or when one of the parts to be joined is too thick to use an ordinary bolt. Foundation bolts. They are used for fixing machines to their foundations. They are made by forging from mild steel or wrought iron rods. Eye foundation bolt. Simplest form of all foundation bolts. In this, one end of the bolt is forged into an eye and a crosspiece is fixed in it. Bent foundation bolt. This bolt is forged in the bent form and set in cement concrete. Machines are to be placed on stone beds. The bolts are set in lead. Rag foundation bolt. This consists of a tapered body, square or rectangular in cross-section, the tapered edges being grooved. A rag foundation bolt that is at first in lead and then in cement concrete. Lewis foundation bolt. This is a removable foundation bolt. The body of the bolt is tapered in width on one side. A key is then inserted bearing against the straight surfaces of the pit and the bolt. Cotter foundation bolt. It is used for fixing heavy machines. It has a rectangular slot at its bottom end to receive a cotter. Nuts. Flanged nut. This is a hexagonal nut with a collar of flange provided integral with it. It is mostly used in a large size hole. Cap nut. It is a hexagonal nut with a cylindrical cap at the top. They are used in smoke boxes and steam pipe connections. Dome nut. It is a form of a cap nut having a spherical dome at the top. Capstan nut. This nut is cylindrical in shape, with holes drilled laterally in the curved surface. A Tommy bar may be used in the holes for turning the nut. Slotted or ring nut. This nut is in the form of a ring, with slots in the curved surface running parallel to the axis. A special C-spanner is used to operate the nut. Wing nut. This nut is used when frequent removal is required, such as inspection covers, lids, etc. It is operated by the thumb. Screw threads. Basic forms. Terms used in thread forms. Minor diameter. This is the root diameter or the diameter on which the thread form is wrapped. Major diameter. It is the outer diameter of the thread. It can be measured easily and hence is used to define the basic size in metric threads. Thread pitch. It is the axial distance from one point on the thread to the point corresponding onto the next. It is an important parameter to specify the thread. Lead is a term similar to pitch, but used with multi-start thread. With 2 starts, lead is equal to 2 into pitch. Thread angle. It is the angle between the flanks of the thread form. Crest and root. These refer to the top and bottom part of the thread form. They could be flat or rounded. Effective diameter. The diameter for which gap is equal to flank thickness. The isometric screw thread. The isometric thread is most widely used. The basic size is defined by the outer diameter and the pitch. The crest angle is 60 degrees. The thread is designated, as in the example, M10 into 1.5 minus 6G. M designates isometric thread. 10 size is designated, major diameter equal to 10 mm. 1.5 mm is equal to pitch. 6G, tolerance class for thread form or fit. Major diameter. The standard sizes are 3, 4, 5, 6, 8, 10, 12, 16, 20, 24, 30, 36, 42, 48, 56, and 64. Pitch. 1. Standard or coarse, and 2. Fine. The fine pitch is smaller than the standard. When pitch is unspecified, the standard is automatic choice. The standard should be selected where strength is prime consideration. Cases where movement is in fine steps or fluid sealing is desired, fine threads are better. Tolerance class. Class used are 4. High precision, 6. Precision, and 8. Coarse. As the name implies, this thread is commonly used in pipe and pipe fittings. It's commonly known as BSP, British Standard Pipe Thread. The dimensions are in inches or fractions of inch, usually multiples of 1 by 32. Normally, tables are available with dimensions in millimeter. The crest angle is 55 degrees. The pitch is normally stated in terms of number of threads per inch. For example, typical designation is G 11 by 4th, where G means it is Whitworth pipe thread. 1 by 4 means 1 by 4 inches is nominal size. Thread crest. D small is equal to D capital. Pitch P. Z is number of threads per inch. Thread height H. From tables, the dimensions for this example is given as metric trapezoidal thread. The ISO or metric trapezoidal thread can carry large torque and popularly used in pipeline industry for valves. The crest angle is 30 degrees. For example, the typical designation is given by some dimensions are given as the square thread. This has large force-bearing capacity, primarily used for lifting devices, especially those working with slow speeds. The square thread. This thread can be considered similar to the trapezoidal thread, except that the force is intended to be in one direction. These are used in quick-release vices. Their designation S20 into 3. S. Designation for square thread 20 equal to nominal dia in millimeters equal to outside dia 3 equal to pitch in mm. The round thread. This is wide application in sheet metal parts, cans, glass, bottles or jars, and plastic containers, designated RD24 into 1 by 8. Keys. Keys are made of heat-treatable steel and are hardened and tempered. Their surface ground to maintain the dimensional tolerances. The shape of the key should be such as to make its insertion into the machined cavity on the shaft or hub easy, and also it should not come loose during operation. For this, some types of keys are with taper, 1:100, and these keys have to be forced into position. Types of keys. Parallel keys. Parallel phase keys consist of countersunk holes which can be provided to seat screws fitted into tapped holes in the shaft keyway. The width B and thickness H are in proportion with the shaft diameter and torque applied. Length is selected as per requirement. Woodruff key. The keyway in the shaft is milled with a round cutter, and keys are machined from a bar, thus easily manufactured. However, the deep cut in the shaft makes it weak, and so this type of joint is suitable for light loads such as FHP motors. The basic dimensions of Woodruff keys are shown here. Taper keys. Taper keys are normally provided with taper 1:100. Matching taper is provided on the hub. Taper key. Taper key is normally used in applications where accuracy is not a prime consideration, but torque transmitted is large and the joint is seldom opened. The large radial forces exerted by the taper keys may cause radial shift and vibration, so these are suitable for low-speed applications. Gib head key. A key with a projecting end that resembles the end of a gib and serves as a stop. The basic dimension of gib head key is given below. Tangential key. Tangential key is placed such that the broadside is along the tangent to shaft and the narrow is nearly radial. There are no specific standard and design are custom made. Tangential key is placed such that the broadside is along the tangent to the shaft and the narrow is nearly radial. The direction of rotation is very important for a tangential key. It is clockwise in case A. In case rotations in both directions are required, a set of 2 will be required. These are placed about 120 degree to 135 degree to each other in case B. Saddle key. The saddle key does not require a keyway or a flat to be machined on the shaft. A taper provided strains the hub and shaft and keeps the joint in position. There are no specific standard and designs are custom made. Round type. Round keys have circular cross sections. Basic dimensions are given here. Cottered joints and joints with types of pins. Cottered joints. Cottered joints are to join together machine members which transmit axial force. The inner and the outer members of a machine are given here. The pin may be provided taper on 1 or 2 faces. The prime advantage of using cottered joints is the rapid assembly and disassembly being possible. This is a particular advantage in jigs and fixtures. Dowel pin. Pins without taper are known as dowels. These can carry only light or moderate loads. Often, these are used to secure fasteners from working loose. Example, ceiling fan. Cotter pin or dowel pin is widely used in the automobiles and many home appliances. The table shows the dimension of standard pin. Knuckle joint. Unlike the cottered joint, which does not allow any flexibility, the knuckle joint allows movement in one plane. The fork and the eye are fastened together using the pin. These are secured in position with a washer and dowel pin. Universal joint. The universal joint has a pair of knuckle joints placed at 90 degrees to each other, connected by a crosspiece. This allows freedom of movement in 2 mutually perpendicular planes used in automobiles' engine shaft. Riveted joints for plates. Riveted joints are for permanent fastening of metal parts. These are primarily used in applications where severe vibration loads are expected. In this aspect, this joint performs better than welded joints. Rivets could be solid or tubular. Tubular rivets are mostly made in aluminum alloys and mostly used in aircraft industry. A hole larger than rivet is drilled in the metal parts. Rivet is inserted. Protruding part of the shank is upset to form a head. Various types of riveted joints are listed here. Riveted lap joint and butt joints are shown here. Typical applications of riveted joints are boilers, ships, bridges, and aircraft structure. Shaft coupling joins two shafts and transfers the torque from one shaft connected to the prime mover to the other shaft connected to the load. Couplings are termed rigid coupling when connecting two shafts which are collinear. Flexible couplings also connect collinear shafts but permit limited misalignments. Flange coupling. The bores in the flange are keyed to the shaft. The two flanges are bolted together. The machined seating ring of one flange fits into the recess into the other, providing easy location during assembly. In some cases, one of the flanges could be a press fit or welded to one shaft. Gear coupling is capable of transmitting very large power and can operate at high speeds. This allows some misalignment. Casing is filled with oil. Oil seals are provided. Muff coupling. Muff coupling is a rigid coupling capable of transmitting very large power. This coupling is suitable for low speeds. It is split along the axis and clamps onto the shaft. This assembly is possible without dismantling shafts. The housing can be a forging or casting. Flexible couplings. Old-arm coupling. These are designed to allow greater shaft misalignments than previous cases. The required flexibility is generally built through interposing a member, disc, provided with protruding tongues on each face and at right angles. The shaft hub has a pair of grooves to seat these protrusions. The middle member is often made of a flexible material. There are many couplings designed and built using the above principle. These are for light power transmission. Some of these are here. Metal spring coupling. The flanges of the housing are bolted together. Hub or sleeve is keyed to the shaft. The sleeves have oil seals to retain oil. The spring steel strip grid transmits power and is flexible enough to absorb shock and vibration. Grid is seated in the grooves on the hub. Well suited for applications involving large power transmission combined with shock and vibration, occurring during sudden start and stops. Example, for elevators. Pipe joints. Threaded pipe joints. American National Standard Taper Pipe Thread, NPT. The taper pipe thread enables rapid assembly of threaded parts. The Whitworth pipe thread is widely used for domestic and industrial pipe fittings. Spigot and socket pipe joints. Underground pipe is usually large in size and weight. Its handling and joining requires special consideration. Also, large misalignments are likely on account of soil settlement. The pipe ends are made with one end in spigot and other in the socket form. A soft material such as fiber rope is used to seal fluid leakage, and seal is kept in position by soft metal fill. High pressure pipe joint. A metal-to-metal sealing is obtained between nipple and adapter by tightening the nut. Components are often joined to pipe by tungsten inert gas welding. The mating pair of flanges are bolted together. Gasket in the middle is compressed by the bolt force and provides required sealing of fluid. Figure shows threaded type plain flange which can be screwed onto the pipe. The SAE type slip-on flange is used with most of the heavy-duty equipments such as tractors and earth-moving machinery, essentially for the ease of assembly. Bearings. Types and application. Journal bearings. The sliding contact bearings limit the motion of shafts and axles to the intended direction, that is, rotation or linear movement. This restraining action causes the bearings to withstand the forces acting on the shaft, which may be radial or axial or combinational. The load is supported by the lubricant film created between shaft and bearing bush. For feeding of lubricant, the housing and lining may be provided with oil ducts. In some instances, the lining may have additional longitudinal and circular grooves to facilitate oil flow. Journal bearing designs are available for axial loads. The shafts are usually made of hardened steel and replacement is expensive. Bushes are made of soft materials. The journals in the form of segments are used extensively. This facilitates easy replacement of worn-out segments. The journal bearings are provided with bushings or line bushes made from anti-friction material such as cast iron, bronze, Babbitt materials, sintered bushes, thermoplastics, etc. Pivot bearings. Knife edges and pivot are bearings in which two members are loaded along a contact line or contact point. The movement could be tilting or limited angular rotation. These bearings are suitable for applications involving large misalignments or relative movement between the two members. Usually, the contact area is small and the contact pressures are large. Hence, relatively hard materials such as high-carbon steels or carbides are used. Example: weighing scales, clocks, watches, etc. Pivot bearings. Rolling element designs for large misalignment. The standard bearing, either ball or roller type, has limited ability to take up shaft misalignments. The self-aligning bearing is for applications involving large shaft misalignments. Y bearings have considerable resistance to angular misalignment, although not suited for positional errors. Thrust bearing double direction with spherical housing washer is shown here. Collar bearings. The collar on the shaft is used to locate the bearing. Usually, a lock nut locates it in position. Similarly, location in the housing is done at the outer race. When shaft is mounted on two bearings, one of the bearings should be provided float to slightly move axially, as shown by the clearance indicated in the figure. For applications where shafts are long, they require to be supported at intermediate locations. Example: shaft connecting marine engine and propeller. The Y bearing is intended for such applications. Where compactness is a premium, standard supply shown here can be used. The complete dimension of the bearing is shown here. Footstep bearings. In certain applications, the shaft is vertical and are required to carry considerable axial load. Radial bearings mounted on the shaft are suitable only for radial location and limited amount of radial loads. One or more axial ball or roller bearings or stack are required to take up thrust loads. The thrust load is transmitted to the bearing through the shaft collar. The housing shown can be part of the machine or fitted on a pedestal. The table gives a summary of different types of standard bearings and salient features of each type in order to correctly select for the application. When the load is applied, the area of contact pressure in the rolling element is least in the case of balls and highest for the rollers. However, roller bearings are least tolerant to misalignments but can carry considerably more load. Summary. Let's summarize the topic. Thread pitch is the axial distance from one point on the thread to the point corresponding onto the next. Keys are surface ground to maintain the dimensional tolerances. Cottered joints are to join together machine members which transmit axial force. Shaft coupling joins two shafts and transfers the torque from one shaft connected to the prime mover to the other shaft connected to the load.